Hello and welcome. My name is Sudi Jawahari and I am a control engineer working at Cybernetica in Trondheim, Norway. In this video, I will be presenting the final demonstrator for the digital twin developed for the gas treatment center at Norsk Hydro's Karmøy technology pilot. The gas treatment center, also known as the GTC, is the focus process of this case. The GTC has two main purposes. The first purpose is to clean the fumes produced by the aluminum electrolysis process of toxic components, primarily hydrogen fluoride, also known as HF. This ensures that the emissions from the aluminum production plant are not harmful to the environment. The second purpose is to capture and recycle as much of the fluoride lost by the electrolysis process as possible. Aluminum electrolysis requires the use of fluoride-containing species. Some of the fluoride is unavoidably lost and transported away from the process by the fumes. The GTC uses alumina to capture and clean fluoride from the fumes. Because alumina is the raw material for aluminum production, the fluoride is effectively recycled by the GTC. Part of the Hydro COGNITWIN pilot has focused on stabilizing the operating conditions of the GTC, specifically the temperature and mass flow rate of the gas flow into the GTC. The figure and video show how temperature and mass flow follow set point changes over time. The data from the GTC is passed to a Cybernetica OPC UA server, where it will be made available for the digital twin. The electrolysis cells are located in the pot room of the aluminum production plant. Because the fumes to be cleaned originate in the cells, data from the pot room is also passed to the server for use by the digital twin. Alumina is the raw material used to produce aluminum and is used by the GTC in high quantities to clean the fumes. Alumina is shipped by boat from Hydro's bauxite processing facilities in Brazil to Karmøy and other destinations. Each delivery of the alumina has its own alumina certificate, which provides information about the quality of the material and its expected performance for fluoride recovery in the GTC. An example property on the alumina certificate is the LOI, which stands for loss on ignition. The LOI, shown in orange, is correlated with the fluoride emissions, shown in blue. The LOI is then a predictive factor for how much fluoride the electrolysis cells are expected to lose when the alumina eventually reaches the pot room. This certificate data is passed manually to the server to be used by the digital twin. The last piece of data used by the digital twin is the weather. The weather is critical for developing an accurate prediction of fluoride emissions. SINTEF has developed an API that can retrieve weather data from the Norwegian Meteorological Institute. The closest weather station to Hydro's Karmøy plant is at Haugesund Airport. The SINTEF API can then be used to develop both recent historical weather measurements as well as the forecast, which allows the digital twin to be used to anticipate future changes in emissions. Both the measured weather data and the weather forecast are passed to the server for use by the digital twin. The digital twin processes all of the data sources made available on the server in order to produce real-time predictions of the GTC. The hybrid digital twin models three types of control volumes: the fumes, the filter compartments, which are each made up of an adsorption reactor and a baghouse filter, and the silos. Each of these control volumes contains dynamic states that are updated based on online input data. The fluoride content of the fumes is measured by an HF laser. The flow rate of the fumes is estimated. The temperature of the fumes is measured both before and after an integrated heat exchanger, also known as an EHEX. Measurements of the alumina levels in the silo and GTC operational parameters are also recorded. Digital twin predictions are used in combination with nonlinear model predictive control to generate an optimized primary alumina feed, which can be used for closed-loop control. The goal of the optimization is to achieve stable and even HF content in secondary alumina, such that the fluoride recycling to the electrolysis cells is stable and predictable. The Cybernetica web viewer highlights the most important current and future variables, such that operators can monitor the state of the GTC digital twin. The video running on the screen shows sped up data from the application running in advisory mode. The interface is in the Norwegian language for operator convenience.